Hi, I am making a video here to quickly go through the sleep deprivation activity, the Tinker Plots part of it, and how we made a conclusion very quickly for you, or as quickly as I can anyway, which hopefully will help guide you as you do the homework. Now, the first thing I want to show you is just how the data file is organized. Notice that we have one column that has the response variable, the improvement scores for all the subjects in that one column. Both groups are there. And the second column has which treatment group they were in, the sleep-deprived group or the unrestricted group. So for the homework, you'll need to have something in the same format where you have the response variable in one column, and then you have the condition variable in a second column telling you whether they were in the real surgery or the sham surgery group. Okay, so now we have our data. Just going to quickly plot the observed data just so we can see how we would do that. So this here is our observed data if I want to plot it and look at the difference in means between groups. I need to put the improvement scores on this bottom axis, so I click on that column, hold my mouse button down, and drag it over here to the bottom axis. I want to get rid of the bins, so I'll do that by changing my bin width to 0. And then I'm going to separate it into the two conditions. So I click on condition, hold my mouse down, drag it over here to the vertical axis, and now I've got it separated by group. Okay, and if I want to look at the means between the two groups, stack it. There we go, it looks a little neater. I can click over here and show the numeric values. And then if I can calculate the difference between them, it's 19.8 minus 3.9 gives me 15.9 as my observed difference between the groups, and that's our observed result. Okay. Now, what I want to figure out is okay, is that observed result something that is unlikely to have happened just by chance if, in fact, sleep deprivation did not impact the improvement scores? The way I'm going to do this is by setting up a sampler to reflect a null model. The null model is that there is no effect of sleep deprivation on the improvement scores, and that the differences that we saw just are because of who happened to end up in each of the groups, just by chance. So I'm going to model that by having two pieces. I'm assuming that since sleep deprivation or unrestricted sleep wouldn't have made a difference, that each of these people would have had the same score no matter which group they were assigned to. So I'm going to take those same scores and I'm going to copy them into a counter. Here's the counter. To copy these in, I click on that column. I go to Edit, Copy Attribute. Then I click over here into the gray part of this box, and I go to Edit again and paste the cases in. Now what I'm going to do, just like we did with the cards in the memorization activity, I'm going to randomly reassign all of these scores to different treatment groups. So I'm going to need a second piece of the sampler to do that. We're going to use the stacks to do it. So I click on that and drag it over here till I get this black box. And there's going to be my stacks. I'm going to need a stack for each of the treatment groups. This one is for the sleep deprived, and the other one can be for the unrestricted sleep group. I had 11 people in the sleep deprived group. I'm going to show my counts, and I want to have that be the same in my re-randomization, so put 11 in the sleep deprived group. Similarly, I had 10 in the unrestricted group originally in my real data, so I'm going to put 10 there. And to make sure that I end up with the exact same sample sizes and not just something that's kind of close, I need to make sure that I sample from this stacks without replacement. So I click down here, without replacement, and you should see this open at the top. That lets you know that it is without replacement. I'm going to rename my attributes. So so that it's easy to keep track of what they are. Improvement and condition. I need to change my repeat to reflect the total number of people in my study. That was 21. And I'll make it go as fast as I can so it doesn't take me all day, and give it a quick run. So there's the first run of my sampler, simulating this null model that in fact sleep deprivation has no effect on improvement scores. I need to plot the results from this first trial so that I can find the difference in means from my first re-randomization, and then I'm going to collect that. So I pull down a plot. I'm going to put my improvement scores on the bottom again and get rid of my bin lines. I'm going to put my conditions over here on the vertical axis. Then I'm going to stack my plot, add my means, and use the ruler to calculate the difference between the means so that I can collect that difference. So to do that, I click on this purple line and I drag my mouse so that I've got a circle right around that triangle. It's very important that you have the circle around the triangle. And I do the same thing at the other line to the other triangle. There we go. Okay, and now it's calculating the difference in means for me. For this particular re-randomization, it's minus 2.94, sorry. So if I want to collect that, I click onto it so there's a box around it, then right-click and collect my statistics. And now I can do additional trials. I'll do 99 more. Collect, and off we go. So what this is going to do, it's simulating a whole bunch of different sort of regroupings of the subjects. So I can see what types of differences we might expect to see if sleep deprivation made no difference, and the only difference we see is because of who happens to end up in each group. Okay, so I'm going to plot this. Pull down my plot. And I'm going to plot this randomization distribution. Okay, there we go. I'll stack it. Alright, so here are my results. Now notice that it is centered very close to 0. The reason it's centered close to 0 is because it's representing our null model, and our null model is that there's no difference between groups with respect to the improvement scores. So if I saw it centered someplace like 10, that would tell me that something's wrong with my model. The fact that it's centered around 0 tells me that, okay, my null model did what it was supposed to do. It simulated results that show me what might happen if really sleep deprivation made no difference, and the difference is 0. The way that I decide whether or not my data provide evidence that sleep deprivation does in fact make a difference is by calculating the strength of evidence. To do that, I need to find my observed result in this distribution of results, which was 15.9, so it's somewhere around here. And I need to decide whether this is something that is likely to have happened if sleep deprivation didn't affect improvement scores, or if it's something that's unlikely, and if it's unlikely enough that I would reject the null model. So I'm going to use my divider tool up here to see what the chance is that I'd see an observed result as extreme as the one that I did, which was 15.9, or even more extreme. So I calculate the percent of my data that's out here. Can see that my strength of evidence, which is the exact same thing as a p-value, so my p-value is equal to 2%. That's saying that if, in fact, sleep deprivation does not impact the improvement scores, there's a 2% chance that I'd have a result as extreme as the one that I observed, or even more extreme. This is an unlikely enough event, less than 5% chance, that it makes me reject my null model here. So I don't believe that there's no difference in improvement scores between the two groups. It's telling me that there is, in fact, strong evidence that sleep deprivation does impact the average improvement score compared to unrestricted sleep.